Hello, today we will continue our conversation with dividing polynomials. In today's video, we will be looking at shortening our steps when dividing polynomials. We will be looking at special properties as well as a special type of division that they refer to as synthetic division. Synthetic division is a special type of division for polynomials. It uses the fact if you have some polynomial f of x and you're dividing it by x minus c, where c is a real number, then the remainder is f of c. So r equals f of c. Using the same rule, we can also note that if f of c is equal to 0, then x minus c is a factor of f of x. Let's look at an example. Our problem asks to find the remainder of the polynomial 3x to the 100 plus 5x to the 85th minus 4x raised to the 38th power plus 2x raised to the 17th minus 6, and we're going to divide that function by our function x plus 1. And again, the question asks us to find the remainder. So typically what we've done in the first video is we would have to write out all of our zero coefficients from 100 down to 0. And then what we would do is ask ourselves, how many times does x go into 3x to the 100? Well, that would take a very, very long time. But the rule that we just talked about states that if you have x minus c and c is a real number, then the function at c is going to be equal to your remainder. And so in this case, we see that we have x minus a negative 1, which means that if we take f of negative 1, that's going to be equal to our remainder. If we plug in negative 1, then we have f of negative 1 equals 3 to the negative 1 raised to the 100 plus 5 to the negative 1 raised to the 85th minus 4 times negative 1 raised to the 38th plus 2 times negative 1 raised to the 17th minus 6. We know that negative 1 times negative 1 gives us a positive, so therefore any even number that we're raising this negative to will turn it into a positive, and then any odd number that we're raising it to will keep it as a negative. Because of that, we know that this is going to be 3 times 1. Then we're going to get plus, that's an odd, so we're going to get 5 times negative 1 minus 4, that's an even, so that's going to be 1, plus 2 times, and then that is an odd, so that's going to be negative 1 minus 6. When we further simplify, we get 3 minus 5 minus 4 minus 2 minus 6. 3 minus 5 is negative 2, minus 4 is negative 6, minus 2 is negative 8, minus 6 is negative 14. And in this case, negative 14 is equal to our remainder, and this is our answer. So you see how this property makes using division substantially easier when you're trying to find specific information like the remainder. Let's try another example. All right, in this case, we have the function x raised to the third power minus 3x squared plus x plus 5, and the question asks us to find the remainder. Well, again, we can use our special property that if you are dividing by x minus c, then f of c is equal to our remainder. In this case, we have x minus 2, and therefore f of 2 is going to be what we're trying to find, and that's going to be equal to our remainder. If we plug 2 into our function, then we're going to get 2 cubed minus 3 times 2 squared plus 2 plus 5. So that's going to be 8 minus 12 plus 2 plus 5. 8 minus 12 is negative 4, plus 2 is negative 2, plus 5 equals 3. And that's equal to our remainder. If we want to do it the traditional way, then we can do x minus 2, and we're dividing that into x cubed minus 3x squared plus x plus 5. How many times can x go into x cubed? That is x squared times, and then what we do, x squared times x gives us x cubed minus 2x squared, and now we're going to minus this. That's going to be a plus. That's going to cancel out. We get negative x squared, and we ask ourselves how many times can x minus 2 go into x squared, and so in this case it's x times, but it's a negative x times. Negative x times x is going to give us a negative x squared plus 2x, and then what we're going to do is subtract these. That's going to cross that out. That's going to leave us with x minus 2x is a negative x plus 5. All we need to do in this case, ask ourselves how many times can x go into negative x, and that's just multiplying by negative 1, and then that's going to give us a negative x plus 2. And then what we do is we subtract these, and this is going to leave us with, cross that out, 5 minus 2 is 3. And you see, this is the same answer as this. However, using our special properties here, it's a lot faster than going through the whole division problem here. Let's look at the next portion of our special properties and see what we can do with that. Looking at our next rule, we see that if f of c is equal to 0, then x minus c, when that's being divided into f of x, is a factor of f of x, and therefore your remainder is going to be equal to 0, or you won't have a remainder because x minus c is a perfect factor. Let's see what that looks like. In this case, we're going to use the exact same polynomial, x cubed minus 3x squared plus x plus 5, but this time instead of doing x minus 2, we're going to do x plus 1. When we have x plus 1, we can use our special property, which says if we have x minus c, then f of c is equal to your remainder. So what we're looking at is if f of c is equal to 0, then x minus c is a factor. In this problem, we have x minus a negative 1, so f of negative 1 is equal to what? If we plug negative 1 into the function, then we're going to get negative 1 to the third minus 3 times negative 1 squared plus negative 1 plus 5. This is going to be a negative 1. That's an odd power. Minus, that's an even power, so that's positive. 3 times 1 is 3 plus negative 1 plus 5. Here we get negative 1 minus 3 minus 1 plus 5. This is negative 5 plus 5, and that equals 0. This tells us that our remainder is equal to 0, and that x plus 1 is indeed a factor of this polynomial. If you wanted to do the long division to check your work, you would be able to see that you would get x squared minus 4x plus 5. However, you would be left with no remainder. And again, that tells us x plus 1 is a factor of this polynomial. Now that we understand some special properties, let's look at synthetic division, which is going to help us solve long division a lot faster. Okay, so for synthetic division, we're still using the special property of x minus c. Synthetic division works if the function that's being divided is following that rule x minus c. If you have a polynomial that's divided by x minus c, then you can use synthetic division. For synthetic division, here are the tips that we're going to go over. When utilizing synthetic division instead of long multiplication, the first step is create a table and supply 0 for any missing coefficients. If you had x to the 6th minus 5. What you would want to do is you would want to do similar to what we did in long division, is x to the 6th plus 0x to the 5th plus, and you would go down until you got to your 5. In this table, what we're going to do is write out the coefficients. So in this case, it would turn into x to the 6th is 1, and then we have 0x to the 5th, 0x to the 4th, 3rd, squared, and then negative 5 is what we were going to have here. And then your c value will go in front of the table, which in this case, we're just going to call it c because we don't have anything. Step 2 is you're going to bring down that first value in the polynomial. So you're going to just draw a line because we're going to have to still do the addition subtraction step like we did in long division, but this is a lot simpler. So we bring down this first value, and this becomes a 1. Next, what you'll do is take that c value, multiply it by your first value in the table, and then place it under your second term. This is stating you're going to take c multiplied by 1. In this case, it's going to be equal to c. We're going to place it under our second term. And then what we're going to do is step 4 is we're going to add our values together. So now we do 0 plus c, and in this case, that's going to be c. Step 5, repeat this process until there are no more terms. We're going to do this again. We're going to take c times c, and that's going to be c squared. That's going to be under your 0. And then what we're going to do is we're going to add these together. So this would become c squared. And we're going to keep doing that until we have no more terms left. Now, your quotient then becomes, which is your answer, you're going to take this as your coefficient. So this becomes 1 times x, and we have to do x to the n minus 1. So in this case, it's going to be x to the 5th, and then we're going to add, and we're going to have c x to the 4th, and then we're going to add c squared, x to the 3rd, and then we're just going to continue that. Now this term under your last value, if that's 0, then you have no remainder. However, if you have that remainder here, then you would have your quotient, and then you would still need to add your remainder. Let's look at an actual example and put this to the test. Okay, let's look at our first example. We're going to use an example that we used previously in the video, and that's x cubed minus 3x squared plus x plus 5, and we're going to divide that by x minus 2. Recall from our rule that if we have x minus c, then we can take f of c, and that's going to be equal to our remainder. In this case, we have x minus 2, where c is equal to 2, so f of 2 is our remainder, and if you recall, then f of 2 is equal to 3. If you want to, you can plug this in. We have 2 cubed, which is 8, minus 3 times 2 squared, which is 4, times 3 is 12, 8 minus 12 is minus 4, plus 2 minus 2 plus 5 plus 3, and that's equal to what we have right here. However, in this case, instead of using long division, what we can do is use synthetic division. Looking at our tips, we need to create a table and supply zeros for any non-missing coefficients. So in this case, we have all of our terms. So we have x cubed, we have an x squared, x, and 5. We don't need to represent any missing terms because we have those. And so in our table, we would just put the leading coefficient. So we have 1, we have a negative 3, we have a 1, and we have a 5. Next, what we want to do is in front of the table, we are going to put our c value. That's what it says here. Your c value will go out in front of the table. In this case, our c value is 2. Next step is we want to bring down our first value in our polynomial. So we're going to bring this 1 down. When we bring that 1 down, we're going to leave it right here. And then we do 2 times 1, and that's going to be equal to 2. And that was step 3. Step 4 is we're going to add the values together. We do negative 3 plus 2, which is equal to negative 1. Step 5, which is repeat this process till there are no more terms. To repeat this process, we do 2 times negative 1. That's going to be negative 2. Negative 2 plus 1 is going to be negative 1. And then what we do is negative 1 times 2. That's going to be negative 2. And then we add these together, and that's going to be equal to 3. Step 6, your quotient becomes the ax minus n with r as your remainder. What this tells us is that this portion is going to be our quotient, and this is going to be our remainder. With our quotient, we are going to do the axn minus 1. So with this, it's going to be 1x to the n minus 1, so that's squared. And then we're going to do minus, and we have another 1, and we're now going to move down the line, and that's x minus, we have 1, and now we have plus our remainder, which is 3 over, and we still have x minus 2. And this is our answer. This is the exact same answer we got when we did long division. If we go back and look at our previous work, we can look right here, and we get that exact same answer. So it's x squared, or 1 times x squared, minus 1 times x minus 1 with the remainder 3. So you see, using synthetic division is a lot more simple than actually going through all of these steps here. Rather, we can use this table and come up with the exact same answer. Let's look at another example. All right, we're going to use another example that we did previously in the video, and that is x cubed minus 3x squared plus x plus 5, which is the same function that we used in the previous example. However, in this case, we're going to do x plus 1, because what we saw earlier was that if we have x minus c, and you have your function of c, and that's equal to 0, then we know that x minus c is a factor of the function. If we remember, right, x minus c is actually x minus a negative 1. In this case, f of negative 1 equaled 0, which tells us that x plus 1 is a perfect factor of x cubed minus 3x squared plus x plus 5. Rather than doing long division to check that, if we wanted to, we can use our synthetic division. And so again, what we're going to do is create a table and supply zeros for any missing coefficients. In this case, we don't have any missing 0 coefficients. So we're going to draw out our table and just put our coefficients down. So we have x cubed, which is 1. We have a negative 3 for the x squared. We have a 1 for the x, and we have a 5. Now what we want to do is we want to put our c value out in front. In this case, c is negative 1. And then what we want to do is bring down that first value in our table. That's what we do here. And then we're going to take our c value, which is negative 1, and multiply it by our first value in the table. In this case, it is 1. 1 times negative 1 is negative 1. Then you're going to take that c value, multiply it by our first value in the table, which we get negative 1, and we're going to place it under the second term, which is that negative 3. Now what we want to do is add the values together, so we get negative 3 plus negative 1, which is negative 4. And now we want to repeat this process until there are no more terms. We take negative 1 times negative 4, so that's going to give us a positive 4. We're going to add that together, which is going to give us 5. And now we're going to take that negative 1 multiplied by 5, and we're going to get negative 5, and when we add those together, we're going to get 0. And if you recall, this is what we got when we did long division. There is no remainder, which then means x plus 1 is a factor of the function x cubed minus 3x squared plus x plus 5. If we look back at our long division, we get the exact same thing here. When we write the quotient out, we're going to put our coefficient out in front of our x value, and then we want to take our first term in our polynomial and reduce it by 1, so this becomes x squared, and then we have minus 4, and then we have x plus 5, and we don't have any more terms, and we have no remainder because that's 0, and now this becomes our final answer. And there you go. We have looked at special properties as well as synthetic division to hopefully shorten your steps when dividing polynomials, as well as when asked for specific properties about the polynomial when dividing by a separate polynomial. You're able to easily solve if we have a remainder and what that remainder is, as well as if that function that's being divided by the polynomial is in fact a factor. If you have any questions or comments, please leave them below. If you learned something and enjoyed the video, please give this a thumbs up, and we'll see you next time.